Welcome everyone, this is Ritesh. Welcome to my channel Dancing with Data. So what I have for you today? We are going to continue our series on Tableau desktop specialization and the skills measure. Today we are going to talk about one of the most important basic building block of Tableau, which is dimensions and measures. Right? You would have seen that whenever you connect to Tableau data source, it would divide the number of columns into dimensions and measures. So what is the basic funda behind that? What are dimensions and measures? How Tableau perceives the same? And at the same time, what is the difference between discrete and continuous fields? So let's get started. What's the difference between a measure and dimensions? But before that, let's also see our agenda. So it's dimension versus measure, discrete versus continuous. How Tableau decides whether Tableau is fully capable of deciding discrete and continuous dimensions versus measures, or you will have to do something from your side. You will have to do some manual intervention over there. Then we'll talk about types of aggregate in Tableau. Last but not the least, continuous versus discrete dates. So what's the difference between a measure and dimension? Measure are numerical values that mathematical functions work on. For example, sales, revenue, you have profit, because you can aggregate that like sum and average and so on. So measures, aggregation makes sense, while dimensions are qualitative and do not total a sum. For example, we have sales region, employee location, date will also come under dimensions. So when dimension and measures work together, they help answer complex business questions, right? For example, you have just dragged sales to column or say rows, you will have only total sales over there. But when you drag the region as well, then you see that, okay, for the region central, east or west, you have that much of sales, right? So that makes sense. Now, just come to the continuous and discrete functions. We talked about dimensions and measures over there, but now we can discuss about continuous and discrete functions. Definition: a set of data is said to be continuous if the values belonging to this set can take any value within a finite or definite interval, right? For example, height of a horse, or maybe your height as well, could be any value within the range of horse height or your height, right? Time to complete a task, which could be measured to fractions of seconds, right? It can be 1 second, 1.1 second, 1.11 second, 1.1111 second. Similarly, for outdoor temperature, speed of a car, you just can't define that. So those are coming under continuous functions. Whereas discrete, a set of data is said to be discrete if values belonging to the set are distinct and separate, unconnected values. The number of people in your class, right? There will be no fractional parts of a person, right? The number of TV sets in a home, the number of puppies, the number of questions on a math test. So these are all defined. These are numbers only, but these are all defined. So this is the basic difference. So now note the continuous data usually requires a measuring device, ruler, stopwatch, thermometer, speedometer, whereas discrete data is counted. Counting is making sense. Description of task is usually preceded by the words number of people, number of TV sets, number of puppies, right? Also, graph, if you try to differentiate graphically, you can see when we are uh, talking about the discrete graph on the right hand side, it is a scatter plot, which is one of the common charts of Tableau. While for the continuous graph, you can draw a continuous function without lifting your pencil from your paper. So you can see the difference. In plain English, a continuous function allows x values to be any points in the interval. So when whatever line that you are drawing, right, you are telling that it can be any point, when you are making that function. While on the right hand side, it says in plain English, a discrete function allows the x values to be the only certain points in the interval, usually only integers or whole numbers, right? So Tableau, now if I come to Tableau, for Tableau it's very simple. All the digits under measures, rest of the fields under dimensions. So here what you should make a note of, right? So if there is something, for example, there they were talking about the number of puppies and all. So I'll give you more practical example. For example, I'm working for an X company. I have my employee ID. That is a number, digit. So that will come under measure. But the property wise count of the employees makes more sense. It will not be fractional, right? Counting of employees makes more sense. It should come under dimension. So that's why you have the option at Tableau. You can convert that very particular field to dimension. Now, I'm going to tell you one exceptional scenario as well. It happened to me a couple of years back when where I saw that I had this employee ID number, and at the end it has some employee space ID. So Tableau was intelligent enough to understand that it is having dimension feature. It was under dimension only, although it was a number, but it wasn't. Because of that, so I raised a request because this is not documented. I rarely wait. That is the only scenario where Tableau will automatically check and it will put it under dimension, a number under dimension. Otherwise, I have not seen any other scenarios. For Tableau, it's simple. All the numbers under measure, non-numbers under dimension. If there is any number having ID at the end, it will take it under dimension. That's it. As simple as that. Now, with respect to Tableau, because we are talking about Tableau specialist certification, there are different scenarios. We'll talk about all the scenarios one by one. Continuous aggregate. This is the most simple one where you have the ship mode and sum of sales, right? And here you can see this is recommended because it is simple to say. For visually, it is more appealing for most of the folks, where you can see directly that okay, under standard class you are having the maximum sum of sales. So this is continuous aggregate, continuous sales in the form of aggregation. Now it can be discrete aggregate as well, where I have turned that sum of sales to discrete. I can turn that to discrete, but this is more recommended. Both are telling you the same information, but this is more recommended. You would have seen people making use of this rather than this. But if you are more familiar with these sorts of visualization, then you can go with this as well. Continuous disaggregate measure, here I have disaggregated that, right? It's in the form of, for example, so that means I've turned my sales. So if I just search for the sales, I've turned that sales to dimension to make it a disaggregate field. How you do that? I'll just right click and convert that to dimension. Sales has been converted to dimension already. So it's continuous, but at the same time, it is continuous. It's disaggregated, but continuous. So in some of the scenarios, you also make use of continuous disaggregate measure. For example, this sort of visualization, it is easy for me to notice that for the standard class, you have sales of 22K, which is far apart from the others transaction, if you can see over there. This is something which is not recommended, where you have discrete disaggregated measure. That means you have disaggregated sales again, have converted that to dimension, and at the same time you have ship mode. You have I have all the sales transaction, and corresponding to those sales transaction you have ship mode. In some of the rare scenarios you may make use of it, but this is not something which is recommended. Coming to the other properties of the dimensions versus measure, so you can see whenever you drag a measure, you get the header, right? And whenever you drag the measure, you get the axis, right? The combination of dimensions and measures will give you more information. So if I just remove it, you won't see the header when you have when you're dragging any measure to rows or column shells. Another difference is you sometimes you do make use of where, for example, I have order date and I have profit, and I turn this to discrete. So I get this. Maybe this makes more sense, right? So if I want to display it like this, I'll have to convert that to discrete, and you can see one difference, that now you have the header as well, because I have turned that to discrete. It's still under measure, so it will aggregate. So anything under measure will aggregate even if it is discrete. One of the other difference that you can see over there is, for example, if I just have something called state and I drag something like discount to color, you can see that it will fill, it will turn to a filled map, right? For the continuous, not that. Whereas if I just drag state to color, it will show you the distinct states over there, different states over there, because state is a discrete measure or it's under dimension. Right? What about dates? Dates are generally by default it would be under dimension, and most of the time you are making use of dates like this, right? It makes sense. But in some of the cases you may make use of dates as continuous feeds like get bar. Here you are making use of continuous, right? So this is the scenario where you are making use of continuous fields. Create this for you. Order date. I will just convert this to week. Now it has turned to continuous. And after that, you have subcategory and ship mode. And you have ship mode. Now I want to get the difference of the order date and ship date. So I'm going to make use of date difference. Date part would be day. I need to turn that to average. And ship mode, come to the color. Order date, again I'll have to filter. I just want range of dates. Maybe I can, for that very particular year, apply, and I get my visualization where it shows me now it helps me to understand that for which subcategory and ship mode combination you have more delays with respect to the other. So that helps. So can Tableau decide on its own? For Tableau, it's simple. All the numbers under measure, non-numbers under dimensions. Yes, in some of the cases, like if your column name is ending with ID, you maybe this you can take this as an exercise and you can do it yourself. Just have one column, name it as ID and have numbers under it, and after that name it something else. Now it will move from measure to dimension, dimensions to measures. You can do it on your own. So this is the so today we talked about dimension versus measures. I hope that it has made some sense, and in the next video we'll talk about the other topics for the Tableau desktop specialist examination. Till then, डेटा ही दाता है, कीप ऑन डांसिंग विद डेटा, क्योंकि डेटा ही दाता है क्या तुमको सब कुछ आता है.